So now let's look at temperature and the zeroth law of thermodynamics. It is a common experience that a cup of hot coffee left on the table eventually cools off and a cold drink eventually warms up. That is, when a body is brought into contact with another body that is at a different temperature, heat is transferred from the body at a higher temperature to the one at lower temperature until both bodies attain the same temperature. At that point, the heat transfer stops and the two bodies are said to have reached thermal equilibrium. The equality of temperature is the only requirement for attaining thermal equilibrium. The zeroth law of thermodynamics states that if two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. It may seem silly that such an obvious fact is called one of the basic laws of thermodynamics. However, it cannot be concluded from the other laws of thermodynamics, and it serves as a basis for the validity of temperature measurement. By replacing the third body with a thermometer, the zeroth law can be restated as two bodies are in thermal equilibrium if both have the same temperature reading, even if they are not in contact. The temperature scales used in the SI and the English system today are the Celsius scale, formerly called as the centigrade scale, and the Fahrenheit scale. On the Celsius scale, the ice and steam points were originally assigned the values of 0 and 100 degrees centigrade respectively. The corresponding values on the Fahrenheit scale are 32 and 212 degrees Fahrenheit. These are often referred to as two-point scales since temperature values are assigned at two different points. In thermodynamics, it is very desirable to have a temperature scale that is independent of the properties of any substance or substances. Such a temperature scale is called a thermodynamic temperature scale, which is developed later in conjunction with the second law of thermodynamics. The thermodynamic temperature scale in the SI is the Kelvin scale, named after Lord Kelvin. The temperature unit on this scale is the Kelvin, which is designated by K. And you have to remember here is that it is not degrees K, it is just capital K. The lowest temperature on Kelvin scale is absolute zero or 0K. Then it follows that only one non-zero reference point needs to be assigned to establish the slope of this linear scale. The thermodynamic temperature scale in the English system is the Rankine scale, named after William Rankine. The temperature unit on this scale is the Rankine, which is designated by a capital R. A temperature scale that turns out to be nearly identical to the Kelvin scale is the ideal gas temperature scale. When you are doing calculations, there are some equations that you'll have to remember, and something that is depicted here is that the temperature in Kelvin is equal to temperature in degrees centigrade plus 273.15, and also the delta T in Kelvin is equal to delta T in degrees centigrade.